And I said,
Think
wait
we're
a
ready.
minute, what time is it?
Mr. President, should we interrupt this crowd? Well, gentlemen, you're probably wondering why I asked you all here today.
No, no, we're not.
Oh, okay. We're going to have a funeral for Elon's latest loss in space. But welcome aboard, everybody. Hi again from the Santa Barbara Astronomical Unit. It happens to be Santa Barbara, California's longtime astrophysics and telescope club. This is our getting to be longtime YouTube vlog, the SBAU Astro Hour. We're about to do for January 20th through the 26th of 2025, program number 204. Soon to be our fourth year of covering the cosmos every week, Monday mornings, 11 to noon. And all our past Astro Hours are archived and available for viewing. Our club is headquartered up at Santa Barbara Museum of Natural History. And as far as outreach, I got to tell you, SBAU is everywhere. I'm your host, proudly, Ronnie Herron, Vice President. I'll introduce you to the rest of the board here in a minute. Go to sbau.org and tell your friends. This week, this Monday morning, the 20th January, our moon reaches apogee tonight, a little more than 250,000 miles away. Private lunar landers are on their way out there. Though Elon lost his big one, the Starship, after launch, got a new term for explosion, RUD, rapid unscheduled disassembly. Add that to UAP, replacing UFOs. We're going to visit yet another lesser known constellation this week, the Lizard. Also focusing on one of Saturn's moons, Iapetus. It's got two tones, F sharp and B minor, I think. Mars is very close. It's in opposition. Visible low in the southwest at night, Comet G3 Atlas pays us a visit every 180,000 years. And then, of course, that awesome and very visible planetary alignment. Let's meet the president first of all. Upper left screen, Jerry Wilson, seventh year.
Good morning, everybody.
There he is. He's got a doctorate, but he doesn't like to talk about it. I consider him sort of our professor. This is an incredible hour for me. He's married to the lovely Pat Forgy. She's a member of the club and a supporter, as is Chuck's Pat. Chuck McPartland is our outreach coordinator, and man, he's everywhere. I heard once 200 times a year. That's
Yep.
not right.
Pre-COVID.
What?
Pre-COVID.
Pre-COVID, you were
like
out.
229 pre-COVID.
That would be at least once and sometime twice a week. Or
Yeah.
more than that, actually.
4 times a week, yeah.
3 or 4. Thank God. His wife, Pat McPartland, is our merch manager, merchandise. They're trying to clean house there with a big yard sale, as well as our incredible taking Colin Taylor's place treasurer. Tom Whittemore is married to Maureen. He's on screen. Baking a lot of bread for us these days. Former Westmont College professor, our connection to their big observatory out there. And how is Maureen? How are you guys doing? You're out. Does she go with you when you set up your scope, Tom?
Not usually. You mean at Westmont?
Well, anytime.
No. Possibly astronomy day coming up.
Ah.
Possibly. I don't know.
I remember her at the Coumadin Clinic. I'd see her there.
Right.
Before she retired. Let's see who else is retired. Tim Crawford, did you ever have a career?
Oh, yeah.
I don't know what it was. Were you out there alongside Hollister in the research and development like the other guys?
Oh, no.
Oh.
I was a dental technician. My dad used to refer to it as an occupation like stacking BBs for a living.
Oh, okay. How long have you been married to Karen?
Oh, man.
Okay, you guys started to get serious about each other then.
Yeah, probably about 40 years.
I think Tom Totten, our webmaster, had a similar job, didn't he? Was he civil employee or something?
He was in the waste management, I think.
I think it was like in the water department.
Yeah.
Okay. And also an incredible telescoper and in charge of the local Santa Barbara Theater Organ Society. Here's Bruce Murdoch on screen. Bruce, good to see you, my friend. He's married to the lovely Bonnie. And we've
been married for 60 years, by the way.
60 years. God, you guys, I'm the only one that's a bachelor. I'm still waiting. Well, anyway, we didn't get too many sillies, but we'll see what the president. Do you want to throw any on the screen at all, Mr.
Yeah,
Clinton?
before I do that, let me just give a shout out to my sister Joyce, who lives on the safe side of the hill in Pasadena.
Mm.
Oh,
She's not in Altadena.
Yeah, came close, but
We have booked your godson. Is it Kakan? How do you pronounce Martin?
Kakan.
Kakan. He will be our July 12th. I think that's a week after July 4th, which is when we would normally have our big summer meeting, but not this July 4th, because obviously the 4th, which falls on a Friday, gets a little crazy. So he'll be there with us. Here we go to the silly stuff we talk. Silly? Oh, is this a silly?
Yep.
yeah,
Bar graph of how much door I've painted. So those are strokes of
the brush.
the brush. I got you. See, I didn't get that one.
No, didn't get any of these.
I didn't get this one either. Two gentlemen, are these actors we should know? Biology majors looking at bugs all day. Ha, I'm crazy. And the guy on the right, computer science majors looking at their bugs all day. My God. Gets rather serious, doesn't it? All right, a couple astronauts looking out the window at the shuttle. One says to the other, dunno, I got a bad
Icarus.
feeling about this. It says caboose, C-A-B-U-S, on the side of
Icarus.
it.
Icarus.
Icarus.
That's why they have a bad feeling about it.
Right.
That went
Icarus
into the sun.
and Daedalus.
Yeah.
He was the guy that used wax as a glue to put
Yeah.
wings on, or feathers on his arms.
And flew too
Flew
close
too
to the
close
sun and up
and
high.
all melted.
Yeah, so that's why they never use that name on a shuttle.
Not
Lord.
on a solar probe.
Yeah, that's fascinating stuff. No more shuttle.
The solar probe is Parker.
Well, let's read this, gentlemen. Imagine if people knocked on your door to talk about science instead of religion. Hi there. We'd just like a quick chat about the possibility of life in the atmosphere of Venus, and thought you might be interested in hearing about phosphine. We're gonna have a speaker in early August talk just about Venus.
Okay,
Dr. Kane of UC
look forward
Riverside.
to it.
Here's a female astronaut. Since
Yeah.
its release 10 years ago in October 2014, only an hour and 25 minutes have passed on Miller's Planet in Interstellar. Oh, that's right.
Did
He
you
went to
see
a
the
black
movie?
hole.
No.
What?
You all saw the movie, I assume?
Yeah.
They
No.
went, Miller's Planet is very close to a very massive black hole, I guess it is. And so on Miller's Planet, time passes very slowly. And they spent a couple of weeks on Miller's Planet. And when the star got back to Earth, his 10-year-old daughter was a dying great-grandmother. And it
Wow.
shows that time, there is no such thing as absolute time, which is assumed in classical physics. That
Yeah,
was one of the great breaks with relativity.
One of those
Yeah.
two twins. One of those two twins, the one that's in Congress and his brother, the one around the Earth.
Yeah.
It's slightly younger now, isn't he?
Yeah, a few seconds or something, or fractions of a second. Yeah.
Well, I don't remember an actress in that movie, Interstellar. Is this from Gravity? That wouldn't be.
No, this is
No,
Interstellar.
this is
Anne Hathaway.
Is that who was in it? That's
Yeah.
what I was thinking. Okay, Anne Hathaway. Fascinating. Even more
I've
fun.
always been bothered about traveling faster than the speed of light because that's got to be relative to something else.
That would
Say
be
that
going back
again?
in- That would have to be going back in time. That would be our true time machine, wouldn't it?
Yeah, everything is back in time. My computer screen is a nanosecond from my eyes.
Is
Yeah.
that right? All right, we got lots to talk about today, gents. Going to take you out. You got a planetary alignment, you got an apogee, and a what's Mars in opposition. And out at Jupiter, they've got what's called perigove and apogee for the.
Now
Juno.
we've got a couple of add-ins since I sent out the talking points. This is a accidental capture of a meteoroid impact on the moon
Wow.
in a video. And let's see if I can.
Is it going to be a
enable the
video? A movie?
What's that?
Is it going to be a video moving? It might be
Yeah,
washed out. I'm not sure.
might be.
It
I'll
is
try to
pretty
work on
washed
that.
out. Yeah.
Let's see.
Plus, you can make it larger. You can fix those two things. Also, that video you sent out or an update from ESA about their Gaia
Yeah,
after 12 years, trillions of data and billions of stars. They're mapping the whole Milky Way.
It's going to be another 5 years before they finish processing all the data.
So, and they catalog new stars that we can't even see with our telescopes. I assume it's a
Like most
telescope.
backyard telescopes, yeah.
Okay. Meteoroids are us. There we go.
Boom.
Hmm.
Boom.
and you can see Tycho down there.
Or we're gonna have a
So they
crater.
estimate this is about the size of, where is it? Somewhere around here.
Breaking news,
Ping
ladies and
pong ball
gentlemen.
sized meteorites.
Another rapid unscheduled disassembly there of a meteor.
Yeah. There was another picture that was of a meteor hitting beside a driveway in someone's home. I've looked at that, but I can't find a citation for it, so I don't know that it's real.
Oh, it's real. It's in
Is it?
Canada.
Okay.
Yeah, this couple, the guy was standing out, or the wife, I don't know who was walking the dog, was standing out there at that spot and then left and walked the dog.
Uh-huh.
And they came back and saw this splat on the bricks and like this 3/4 inch ding in the bricks. And they checked there, and there was all this kind of gravelly stuff laying around. And they said, "Well,
Okay.
what could have caused that?" And they looked at their Ring doorbell video, and they got not only video but audio of the meteorite hitting.
Oh, wow.
So I guess that's a first of
Yeah.
the actual hit of a meteorite.
The first sonic one, anyway, first
Yeah.
sound recording. Yeah.
Didn't somebody else get part of Elon's Starship, or did that all go into the Atlantic?
I know there were complaints about the debris fall. I don't know if they might have picked it up from a ship, something floating
No,
out
there's
there.
one tropical island in the Bahamas said that their beaches are littered with debris.
Ah,
So it either washed ashore or landed on there. Can you see this, Share?
yes.
Okay. So this is, I sent you last night, I sent you a video of the results of the European Space Agency's Gaia satellite.
Right.
It's going to be and this is an artist rendition, obviously, of our galaxy, showing summarizing the results of the shape of our galaxy. It's got a flexure to it like this, primarily believed to be due to interaction with something like the Large Magellanic Cloud or some other nearby one. But the statistics on that are just absolutely astounding. Do I have that here?
Potato
No.
chip galaxy.
Yeah, they have made trillions of observations of billions of stars in our galaxy, getting proper motions and information on where they are, and
And
doing it very
their positions
that?
on asteroids and stars are so accurate that now occultations, positive occultation hits have gone up almost exponentially. If you look at the number by year,
Uh-huh.
just rocketed up because now the predictions of the shadow paths are much, much more accurate.
Okay.
Due to that Gaia,
Yeah.
and even though we're in the middle of what we're looking at, we can tell it's shaped like that. That's insane.
Well, we know what it looks like in 3 dimensions because we make a map in 3 dimensions. And so once you have that data set, then you can generate a picture from any angle.
Huh.
And distance. So this is what we can expect for January. The 21st of January is tomorrow, of course, and this will be the 3rd quarter or the last quarter moon. So from here through new moon and over to 1st quarter in February, this is the January date, but in February, that's when astro imagers, if they get clear skies around here, can go nuts. Get good faint fuzzies.
If the clouds behave.
Now, this is another video. Let me just stop sharing it. It's pretty cool. So I just threw it in here.
It's really contrasty.
Yes, and that's a problem with the way things display on your screen from this. So let's see, where are we?
What's the backside?
Can you see it or is it washed out?
It's
You can
decent.
see it.
Okay. So this is showing the moon, all sides of it. This we don't get a good view from our Earth perspective. This is, of course, the backside of the moon here. Very few lava-filled large craters. Come around with, this is Mare Crisium, I believe.
Yes.
And then now we're down to the front side again. There's a Tycho down here. And there's another one that's on the dark side, excuse me, the backside. So they have their ray craters back there too. Nice ray complex there. Nice graphic.
Well, some of the rays of Tycho go all the way up to the North Pole of the moon.
Yes.
Can I ask a question?
Go ahead.
You just did.
If any of the space companies of the Earth, of the planet here, like us and China and everybody else, lands on the side that we see, we don't have to have an orbiter retransmitting from the surface. But if China goes to the other side, they're going to have to go by way of an interim.
They already did that, Ron.
Well, in other words, they're on the other side. They'll always be on the other side. They won't be able to beam directly to the Earth, will they?
Right.
Okay.
Yeah, they beam to an orbiter.
Yeah.
And when when the orbiter comes around, then it can transmit to us.
And that's going to be less of a problem in the future for both Mars and Moon, because the plans are loosely to build an infrastructure around each planet with GPS systems and communication satellites. So nothing will ever be out of communication with Earth.
And chances are the earliest colonies will be on the poles, won't they? Because that's where the water is.
South Pole, yeah.
You suppose they'll be out there with chisels and hammers on
I
a
think
lake?
they'll be out there with pipes
Drill.
and heaters.
Yeah.
So this is a picture of the Firefly company's Blue Ghost Mission 1 separating from the booster in space and heading on its way toward the moon. At this particular point, it's at 442 kilometers altitude from Earth and traveling at 37,103 kilometers per hour. So that's about orbital velocity, 17,000 miles an hour. Little faster.
Is that Bezos's company or Branson?
Neither one.
I don't think that Branson's involved in that.
37,000 kilometers per hour is 22,632.
Okay, yeah, it's faster.
Pardon?
It's faster than 17.5.
Yeah.
Well,
Yeah,
this
Yeah,
is-
it's 22.6.
yeah,
They're heading for the moon.
eventually.
Yeah.
And
So
it's
this
not-
is Firefly Aerospace. That's the company.
It's not
And
NASA.
this project is called Ghost Riders in the Sky, and the Lunar Ghost is its capsule. So this
Wow.
is how it's going to operate. These are why it's faster than 17,500 miles an hour. It's because it's got orbits with higher apogees. And as it goes around, the apogee goes up because when it's down here, it gives a little push. And so that makes it go higher on the next orbit around. And then up here, it gets fast enough that it will be in a lunar traverse or a transfer orbit. And then it will be in large orbits around the moon. And it will, as it comes in apogee here, is that right? Let's see, then it gives a little retard firing at the thing. And so it lowers its perigee until finally, after 17 orbits, it will land on the moon. So it's going to, once it's around the orbit, it's going to orbit the moon for 16 days. The entire thing is going to take 60 days. And it's going to take one hour to descend to touchdown. And then it's going to be on the lunar surface. The science data taking will be done there. And it will operate until lunar sunset. And then it will operate a few hours into lunar sunset in the night. So they're testing the engineering of what happens to all their stuff when it goes into lunar night. And they're expecting that the lunar night is going to kill the satellite. So that's mission end.
Because it's so cold?
Yes.
And their batteries run out.
Yeah.
Well, I was hoping they might have battery protection, so when it gets below a certain point, they just go into a sleep mode or, hibernate mode, and then
They
finally
might, but if they did, it wasn't in the write-up I read.
Yeah, they're figuring they're losing it.
Does Firefly launch from Texas?
I think this was launched from Florida.
Oh, so they use Kennedy, they use Canaveral.
Yeah.
Yeah, most people do.
Thought that was exclusive NASA. I guess not.
Yeah. iSpace with a small I. This is a Japanese company, Hakutor R, and this is their mission, iSpace. And this is their second attempt at this. It's also going to take some time to get there, but it's a more direct mission. So it's going to go pretty much directly on deployment of all its instruments, establishment of a steady operation state, completion of first orbital control maneuver, completion of lunar flyby. Then it's going to enter a lunar orbit. And a flyby doesn't mean like one fly pass. It means, well, it does mean one pass. The lunar orbit means multiple passes to map the surface.
And Jerry, these guys are doing not the direct flight. These guys are doing the long multi-orbit until you keep raising your apogee until you manage to get to a lunar capture orbit. So they're going to take months to get there for this one.
But that's the same deal as this for Firefly.
Except Firefly's doing it much quicker. They're doing an actual rocket burn.
Okay. So then they'll complete all orbital control maneuvers in lunar orbit, completion of lunar landing sequence, and then they'll establish a steady system state after landing. This one is not expected to go dead at lunar night. Oops.
And their last one was the one that tipped over.
Yeah.
Oh,
And still worked.
Yeah.
But unlike Apollo, these suckers stay there where there's no people on board, right?
No people.
All right.
has this launched?
Yes.
Maybe some bacteria and fungus, but no people.
Pollute the moon.
Now, for some reason, this little red house is on the iSpace lander.
Really?
It's by a Danish artist who talked people into putting his thing on the lunar lander.
A log cabin?
Yeah. Now, this is the very spectacular re-entry of pieces of Starship 7 over the Bahamas or over the Caribbean.
It's really burned out.
Yeah. Oh, is it? Okay.
Yeah.
Let's give this a try. Same?
A little better.
Well, the lower part is burned out, but you can definitely see the debris trails.
Okay. Well, the lower part is just white clouds, so it's not anything spectacular. But there are videos online that you can read that show the actual explosion of the starship. And then all these spectacular parts that eventually slow down and flutter to the ground.
This is the latest one that failed.
Yeah,
Yes.
Okay.
Would it be fair to say that it didn't reach orbital speed because it came back down, but it's still going, what, 10,000, 15,000 miles an hour?
that's a good question. It's definitely in the atmosphere with all those particles. It may have blown up above the atmosphere and then come down into it, or it may have blown up in the atmosphere. I'm guessing that it was actually firing its engines at the time it blew up.
Yeah, it blew up in the atmosphere, I think.
Well, what was it going to do? Just orbit the Earth, or they weren't sending it to the moon, were they?
No, it was just an orbital test.
Just
Right.
an orbital.
Yeah, they're testing, what they do with the last one, number 6, they had it fly over, I think it was the Indian Ocean,
Mhm.
and then land on the Indian Ocean surface as if it was solid land. Just low down, and it touched the water and then shut its engines off and then sank. So if anyone wants its technology and they have a deep ocean diver thing, they could get it. So
Have you
now
seen?
this is a little known target called the Lizard,
Oh, we're
less-
into the lizard constellation.
Lacerta. There's a couple of things in here that Astronomy Magazine pointed out. One is IC 5217, which is a open cluster. Oh no, that's the planetary nebula.
Mhm.
And NGC 7243 is an open cluster. And you can see the open cluster right there.
Huh.
See the little circlet of pinpoint stars? That's the open cluster. And then a
Those-
remarkably difficult planetary nebula here in 5217.
Would those 4 stars, Jerry, be the head of the lizard?
Mhm.
And like all these little closed things, it's called a circlet of Lacerta.
Never seen this one.
This one, just the brighter stars here. That's the
Yeah.
problem with photographs. It brings out all stars in a rich area like this. But just these brighter stars here out there, and seems to be surrounded by the dark little
Holy
ring
mackerel.
there. This is the open cluster.
You suppose that Gaia mission from a European has got data on every damn star we're looking at here, every one of those
I'm
dots?
pretty sure, yeah, if they say billions of stars that they examined, at this level where an amateur photograph is going to take pictures of stars like this, I think they're at the billion level.
How many of them aren't named? More than we see?
This is Irene down here.
Yeah.
Irene.
Um,
Good night, Irene. Good
I
night.
have no idea. Look up you can't look up all the star charts and then total all the numbers because they duplicate each other. So you take the biggest star chart, see how many entries there are, and that's how many named stars there are within an order of magnitude.
Yeah, the Gaia catalog, they all have numbers,
Yeah.
It's G, and then they encode the right ascension and declination to find levels. So it's a big long number.
Wow. And there's a vast part of the galaxy we'll never see because of that big long column.
There was a science fiction story I read back in the 50s when I was in junior high called The 9 Billion Names of God. And this guy, they had developed computers at that time, and this guy was an astronomer and he was using computers, and he had decided that the whole purpose of civilization was just so that humanity could realize all the combinations of God's name. And there were supposed to be 9 billion names. And once they'd written down all the 9 billion names of God, the earth would end. And so they said, well, that's ridiculous. But he set up a program to try it, and the program generated the 9 billion names of God. And then it ran the computer, and it was going to come up with its final name. about midnight, and that was just when he was walking home. And as he was walking home, he looked up at the sky and he saw the stars slowly going out. So that was, and the illustration of that is not religion, but it's how big numbers at that time are trivial numbers today.
Yeah.
So this is a image of the planetary nebula.
Jesus.
IC 5217 in Lacerta. This is a magnification of that image with no filter. And it's easy to find because it's 1/3 of the way. It's close to 50% of the way between these two stars. So it's not that difficult to find for we star hoppers.
And those two stars are named?
So from now on for the next 2 weeks, if you get a clear sky, this is a good object to try and find. This is a close-up of that same planetary nebula. It's also called, I think it's called
Little Saturn.
yeah, it somehow has Saturn in the name.
Little Saturn. And
Yeah,
it's
this is a hydrogen alpha and a nitrogen 2 image.
Huh.
There's another Saturn nebula, Ron. So that's why
Yeah,
this
that's
one's
what
called the Little
confused me,
Saturn.
was that this is the Saturn nebula I knew.
But are all the little orange dots, are they stars?
Those are no. It's fluorescent gas, Ron. It's a planetary nebula. So those are just
This-
pixels.
Yeah,
What's
this is
the
a
bright-
white dwarf in the middle.
Oh, is that what that is? A dwarf?
White, yes, right.
And yet we can see it.
It's a planetary nebula. That's what's in the center of planetary nebulae, is a white dwarf star.
Yeah.
Well, I thought they were the size of the Earth,
They are.
and yet we can see it. Wow.
Yes, they're super hot.
They're like 30 million degrees.
And you're not seeing the star itself in that image. You're just seeing the fluorescent gas.
Right.
But it's a nursery for new stars.
No,
Oh, isn't that what a
dead
nebula
star.
is?
It's a dead star.
I'm talking about the nebula itself.
Yeah, it's a dead star where it's barfed off its outer layers.
Oh, I see. Okay, got it.
Yeah, that's star barf.
Yeah.
Speaking of Saturn,
Yes, speaking of Saturn, good segue here. Now, the reason this is on here is because the moon Iapetus is the moon that is half black and half white. And so depending on which side faces us, you can see it bright or it's very difficult to see it at all. I think it changes by 2 magnitudes or something close to that. And so that it happens when the moon is at its greatest extent from Saturn. One side it's dark and on the other side it's white. Here you see it's right above Saturn, so it's not extended from Saturn because it's in the plane of Saturn's rings roughly. And so it's right over, so it's you see half of it right now. You see half the black and half the white. So it's like a first quarter moon from Earth. So it's a unique opportunity to see it and to see the magnitude of the two combined together.
does science know what the black and the white are?
The black is polycyclic aromatic hydrocarbons, so basically barbecue gunk. The white side is water ice.
Yeah.
It wouldn't be like the big heart shape on Pluto that's, I think,
No, that's nitrogen ice.
nitrogen ice.
It's a lot colder.
Iapetus, is that an ancient Greek god or?
Of some kind, yeah.
Fascinating.
Our dog walker just showed up and the dog went nuts.
He's getting out. I'm free. But old man Galileo didn't find the moons around Saturn like he did Jupiter, did he?
Now, this
No, he
wasn't included in the talking points.
Aha.
He didn't even figure out it was a ring around around Saturn.
He thought it was a planet with jug arms or something.
Yeah.
Well, his
Animals with
telescope
big ears.
objective lens is only about 1.5 inches in diameter, right?
Yeah.
Yeah.
30x was his max, I think. And it was Huygens, like 60 years later, that figured out it was a ring, and it was Huygens that found Titan around Saturn.
And Saturn has more moons, doesn't it, than Jupiter?
146.
Versus how many around the Jovian?
95.
Oh, okay.
12 and 9 from my age.
Yeah.
When I was a boy, we thought that I think Jupiter had 12 and Saturn had 9.
Yeah, I remember that.
Yeah.
Yeah.
I tell people that at star parties, and I said, not to age myself, but
But
yeah.
What are we going to tell people at the star party when Saturn goes edge on? And
we
the
won't be
ring
able to see that because it's during daytime for us.
Oh, no kidding! It's only short-lived.
Yeah.
Yeah, hours.
Well, yeah, but there's not much ring to see before and after that happens, I'm sure.
Yeah, it's very linear now.
Is it? Okay.
We could tell them, wow, it must have disappeared.
Yeah.
Trust me, that is Saturn.
Now, this is Jupiter.
Aha.
Showing retrograde motion.
Yeah, this is giving a very, it's a nice graphic to illustrate prograde and retrograde motion.
Oh.
You see the video, right?
Yes.
Yes.
Okay.
It's like a comet.
Now let's watch it again. So this is this would be going east, that would be prograde. Because Jupiter appears to be going in the way that it's really going, but it's going faster than it appears, or than it is in its orbit. And then we pass up Jupiter, we catch up to it, and we pass it, and that makes it start to look like it's going backwards. That's just because one car passing the other one, it looks like the other car is going slower than you, so it looks like it's backing up.
Oh, wow. That's a really interesting illusion. I never heard that one. Thank you, Jerry. That's a really nice visual.
Yeah, I thought it was too.
I'm not sure I totally understand. We need a little more.
We're
looking down
passing it on the inside track. And so from our point of view, it appears to slow down, stop, go backwards, and then start following us again.
Okay, that's retrograde, which we get from
Now,
it's not retrograde?
Well, that whole thing when we're passing it is retrograde, but then it turns back to prograde
yeah.
after we pass it.
But
So
now-
people saw this in the sky. The bottom picture is what you see with the naked eye. And so people saw the planets, the wanderers going one way, then they'd stop and go back. And that's why they thought, since the Earth is the center of the solar system, that these things moved in hypocycloids, I think they were called, cycloids. So they had this complicated motion. They were not in actual just elliptical orbits.
That was the
But
whole Ptolemaic
because-
system.
Yeah, the old Ptolemaic system. And they made the math work for this. So, which means that you get enough in mathematics, we used to joke in physics that if you have enough independent variables, you can make data fit the outline of the state of Texas. So you can fit any motion you see to some mathematical function. It doesn't mean it's the right mathematical function.
You do Fourier analysis on it too.
Yep. So, but this was the thing that Copernicus published, but he thought it was too radical, and so he had it published posthumously.
Wow.
So this would be similar to, what is that called? The graph of the sun when you come out and take a picture of the sun every day for a year.
Analemma.
Yeah, analemma.
yeah.
So this should be similar to that, right?
Yes. Except Jupiter.
Interesting.
I
Except
thought it
Jupiter,
was
yeah.
Galileo that had his findings published posthumously.
No. That was
Oh.
Copernicus.
All right.
Okay. Let's get back to where we
Copernicus
were.
was the one that set him straight, I guess, huh? And Kepler.
Well, sort of. He still said it was circular.
Oh, he did. Okay.
Closer than
Galileo would have been in
cycloids.
better shape if he had done his posthumously.
Yeah.
Mars.
Yeah, so this is a picture, a very nice photograph taken by Damien Peach.
Hmm.
And I don't have the details on his instrument, but it's taken on that day on the 15th, within a few hours of opposition. So this is at 14.5 seconds of an arc across. You can see the southern polar cap. You can see a cloud over here, and all sorts of interesting features in here.
Did you say the southern was at the top?
Yes.
Yeah,
Okay.
Where is Valley Marinaris? Is that thing right in the middle?
No, that's
Syrtis Major, I think.
Syrtis Major, Syrtis Major. Looks like Africa.
And Hellas. I don't know where Hellas is.
Hellas is the big basin probably down below it there.
That, yeah.
And that cloud on the right limb is probably an orographic cloud over Olympus Mons.
Yeah.
Whoa. 15-mile high mountain.
Yeah, they
Yeah.
say it's a bright Elysium cloud, but they
Oh.
don't say it's
Okay, that's not going to be Olympus Mons then.
okay. Yeah. But Olympus Mons does generate clouds.
It does.
Yes.
How do we get the southern hemisphere, the southern polar region at the top? I don't understand that.
That's putting a diagonal in your telescope.
You mean it's backwards?
You know that when you take pictures of the moon, and you see it with your naked eye, it's there, the orientation is always flipped one way or the other, it seems.
Not
So
in my scopes.
You learn one orientation, and then you see it probably the way it really is, and you get confused. At least I
Yeah.
do.
Most of the time, astronomers don't care if it's a flipped view, so
Right.
often south is up.
Huh. But aren't all the planets aligned the same? Their north poles always
Well,
point.
that's just a convention that we call it, but they're not. Uranus is
Yeah.
pointed toward the sun in a way.
Yeah,
Well, Uranus is sideways, isn't it?
Yeah.
pretty much. Yeah.
Well, I get that comment at star parties a lot too. People look at my scope and they say, "This is backwards." No,
Backwards.
it
Yeah.
isn't. I have a diagonal, roof prism for my diagonal, so it doesn't flip things left to right.
I'm reminded of the guy that I put my telescope on one of the oil platforms before it got dark, and it was a straight through. I didn't have a diagonal in it, and the one kid was about an 8-year-old kid was there, and he looked through it, and then he started trying to rotate the eyepiece. So that is the kind of thing. That's how I learned optics, because I remember I did that too. I tried to rotate the optics at one point, and you start thinking, well, that didn't work, and then you start thinking about why not, and that is the start of science.
But we are as close as possible right now to Mars, right? We're passing
No.
it.
No. Well, we're closest for a 2-year period, but we were much closer back in 2003.
Yeah.
Okay, well, how
Because
many?
its orbit is it's pretty elliptical compared to ours.
Yeah. In 2003, Mars was 25 seconds of an arc in diameter. This is 14. So if this had been a close opposition like that, Mars would be almost twice as big here. Be out to about there. So a lot more detail would have been visible.
Okay,
And
you're talking about minutes and seconds of size in the sky, aren't you?
Yes.
Yeah, it's an angle.
But you said arcs.
Yeah, that's arc. That's
An arc is the same as minutes or
no, an arc.
minutes of arc, seconds of arc.
Yeah,
oh, okay.
as opposed to linear.
It would have been 79% wider at the last opposition than now.
Well, how many orbits does the Earth get for every orbit of one orbit of Mars?
2, roughly.
Couple.
About 2, huh? And during that same period, Venus would go what, 3 or 4 times?
9 months.
No, I'm talking about it's inner, so it would go
Yeah.
faster. Or
9 months for Venus's year.
oh, I see. Gotcha. 3/4. All right. Here's a beautiful sunset picture. Oh no, it's our favorite comet, old G3 Atlas, right?
Yes,
Got it.
it's putting on a very nice show in the evening here all of a sudden.
For the southern hemisphere, not so much for
Yeah,
us.
for
Yeah.
us.
Yeah, but you can catch it from the north here, but it's really fleeting.
Yeah, I think that period is past.
Oh, you think so? Okay.
Yeah.
Well, all the pictures I have are from the past.
Yeah.
Those aren't
So-
our palm trees.
This this is from Kevin Parker. He's a regular, but I don't recall where he's at. And this one oops, is from
That's
Chris
his scope.
Schur. He has a 10-inch f/39 Orion telescope, heavily baffled here. So he's got 2 light shields on it. And it looks like he's got a what
A
is that
solar.
one?
Looks like a Lunt solar.
Yeah.
Yeah. And
An astrophysics
moonlight
mount.
focuser on it and a ZWO camera. So he took this picture on January 12, and when it was only 5 degrees from the sun. He reports the sun, the nucleus is a single stellar object, and it does not appear to be breaking up.
And
And
that's
it
something.
didn't
Elongation will
break up,
remain.
and they're getting a great view now from the southern hemisphere.
Yeah. So it will remain 5 degrees from the sun on the 13th, this was 7 days ago, and
Wow.
increased to about 6.5 on the 14th. His image that's shown here is 250 stacked exposures, each of 0.03 seconds, 3 milliseconds. Oh,
30 milliseconds.
30
milliseconds,
milliseconds.
right.
And somehow they calculated 180,000 years for its orbit.
Yeah, so this will go out back we're home, and then we will not see it again in our lifetimes.
Got to be the Oort cloud.
Unless they make many medical breakthroughs here in the next few years.
A whole lot, yeah.
Okay.
So I'm trying to decide if from the way he's looking at the sun and the way his thing is oriented, if you can tell if he's in the northern hemisphere or the southern hemisphere.
Northern hemisphere. Because if that's an astrophysics mount, that
Yeah.
side with the counterweights is toward the north.
Yeah. Yes.
Really?
Okay, good.
If it was south, it'd be on the other side.
Oh, but can we tell? Because if he was in the southern hemisphere, he would
Have
be
it
pointing
point
at
at the southern pole.
Yeah, yeah. I don't think we can tell for sure, but I think Chris Schur is northern hemisphere.
Okay.
I think he's in Arizona.
What did you call those 2 mounts in the forward part of that telescope? What was that called, Jerry?
These 2 silvery things,
Yeah.
those are light shields. They're flexible. You wrap them around the end of your telescope, anchor them, and then it's got a Velcro strip that holds them together there. And he's got 2 of them mounted there. It's to keep stray light out because he's working during the daytime.
They probably have black felt on the inside.
Yeah. So if you go, they used to tell this, I never tried it, but when I was first making mirrors back in the 60s, reading those Scientific American books, how to make, I forget the name of them, amateur telescope making.
Ingalls.
They would point out that if you were at the bottom of a dry water well and you looked up so that you didn't have stray light, it's like looking up a long tube. During the daytime, you could see stars because of the skylight that it blocked out.
Wow.
So I assume it's true. I've never tried it myself. I have any water
Yeah, I
wells
think-
around here.
I
And I'm
think that one might be
claustrophobic.
an urban legend, but
It could be.
Well,
So
every
it's
there
high
you
enough
s-
in the atmosphere. If you're in a plane flying high, you can see.
Yeah, because the scattering of light is less.
Yeah.
I was going to say the same thing.
light shield, the equivalent of a silencer on a gun. It's got two of them.
And at night, it's a dew shield.
Yeah.
Man, fascinating.
But the blue sky is not locally generated in the shield on your scope. It's our atmosphere,
Yeah.
scattering of light in our atmosphere.
Yeah.
Boy, we could have used some dew shields up at Westmont.
Yeah, it was a
Oh,
wet
yeah.
night.
It was a wet night.
Well, I seem to see a correlation between when I walk out my deck and look at the night sky and it's really clear. It's also the humidity is quite high. Everything's wet.
Right?
Yes.
That's not good, huh?
Not for
Well,
optics.
with the cardboard tube like I've got, not good.
Cardboard? You kidding me?
No, it's a
I thought yours was soaked in some sort of resin.
Black
it's
painted
just
cardboard works fine.
epoxy paint. That's it.
But the radio wave ones that are concave are big and they don't need a tube. Radio waves don't do what light waves do
Yep.
they?
Waves are waves.
Well, I
Wave
know.
back.
I don't know.
You could, Ron, you don't need to have the tube on the telescope.
That's
It's
what
just
I'm,
there to keep out some stray light, but you're going to have less trouble with stray radio waves, I think.
Yeah.
is that right?
The sun doesn't put out a lot. Oh, by the way, I've read a couple of times that the sun last week put out a couple of X1.1 flares. And they're
Oh.
waiting to see if we got any CME from it I don't know if we did.
Well, next week we'll talk
You
about
look
it.
at the, with the reflection, you don't have to have a tube. Look at the one that Jürgen Hilmer made. Everything's exposed. There's just a mirror and a post and a little post to hold the diagonal and the eyepiece.
I see 6 planets there. Plus us would be 7. Where's the 8th? Mercury?
Yeah,
Mercury's not in the sky until February.
right.
Okay,
So-
but this is the big lineup that they're all bragging about.
Yeah, this is
Yeah.
the big lineup and it hasn't happened since yesterday. And
Yeah.
it'll happen again tomorrow.
Wow.
So this is the ecliptic. All the planets line up on the ecliptic every night. Of course, you can't see them all in one snapshot every night. You have to wait till they come around.
And the moon will be out of the picture now because we're heading toward third quarter.
Oh,
Okay.
yeah.
But I could see 4 planets naked eye last night.
Yeah, this, you see moon next to Mars. This was the time of the occultation.
Yeah.
And the moon was full.
If Betelgeuse ever decides to blow, will it act like a full moon? You suppose we won't be able to see half the stars?
It probably won't get that bright.
Yeah.
Oh,
It'll be bright enough to see in the daytime.
Yeah.
and it still may not happen for 100,000 years, right?
If
Yeah.
you know where to look now, you can see Venus in the daytime. It's
Oh,
not
yeah.
too near the sun.
Oh, Chuck does that all the time.
And Mars and the moon are still occulting each other.
No, this is
No, that was
January
only for a
13th.
couple hours.
Okay.
That lasted an hour.
They
Right.
moved
Less than-
on. Okay.
Yeah.
Last Monday.
If you have time at the end, I want to ask a question on the moon.
Well, this is the last slide, so go ahead.
If on first quarter, about a day after first quarter, we get to see Rufus Recta, the sword on the moon. Can we reverse that at third quarter? Can we actually see the sword on the moon, or is that cliff facing the wrong direction for a shadow?
I think that's the case. It's the wrong
Yeah.
direction.
You can certainly see
Yeah,
the area of the
that's what I'm
sword.
Yeah. And you can probably
Yeah,
see the
it's-
handle, of the sword.
But not that escarpment.
It wouldn't be if you see it, it wouldn't be as well defined. You might be able to pick out the scarp a little bit, but it would be much thinner looking.
Yeah. Yeah.
So where would it be in here?
It would be right to the right of the shadow, I think, of the triplet, right at the terminator. The triplet below. Yeah, those are the triplet there. And I think it's either to the right of those. It's hard to
Okay.
know because what you have to do is check out little Burt crater.
Oh, okay.
Well, that meteorite you showed us earlier,
I think that's right.
that meteorite that crashed into the moon earlier, Jerry, is that now a new crater we can see?
It is a new crater, but I don't know that you can see it from Earth. Usually they look for it in another pass of a lunar orbiter, and they can see the splatter from that usually.
Yeah,
Plus,
it's going to be tens of feet across at most, I think.
Yeah.
Oh. Well, we can't see any of the landers that are up there or anything. They're just too damn small.
not from Earth.
Not from Earth, but the rovers can actually see the footprint trails.
And you can't see from Earth any of the moons on the outer gas giants, Uranus and Neptune. You can't
Sure.
see their moons.
Sure. Well, with telescope, sure. That's how they
Oh,
were
you can.
discovered, a lot of them.
Yeah.
But not all of them. The little ones.
Not the little dinky ones.
Okay, got it.
That's why the count went way up when we got space telescopes and space probes. But traditionally on Saturn, new moons were discovered when it went through a ring plane crossing and the rings disappeared.
Right.
Their brightness overwhelmed the dim little moons near Saturn.
And that was done by Cassini, right? 20 years ago?
No, people on the Earth with telescopes saw they discovered moons when the rings edge
Before
out.
Cassini.
Yeah. For the Cassini mission. I thought at first you meant Cassini the astronomer.
Oh,
Well, you're an Italian guy. There's a lot of Italians, and when
Actually,
we do our
he was
next,
Italian, but he was
working
working in France.
Yeah, he worked in France.
yeah.
he did. Okay.
Mhm.
Well, he certainly got his due.
Wow.
Next star party, which is about 4 weeks away, any of these planets going to be gone or moved on out of the
Nope.
picture? They'll all
Nope.
be there. They'll all still be there.
Venus now will start moving to the other side of Saturn.
Okay. Does show Venus is a bright one. And I don't know how you get a hunter out of that Orion configuration. That looks like a terrible assignment in geometry.
Well, you gotta put in his bow here. And then you can start imagining that he's got an arm to hold the bow out there.
Right, and also the arm that holds the club.
Yeah.
Yeah.
Yeah, that's up by the word Betelgeuse.
Yeah.
Yeah.
And traditionally that bow is a lion skin shield that he's holding up because he killed the Nemean lion that had impervious skin and people couldn't kill it, but he killed it by strangling it.
Huh.
And Betelgeuse represents what is his arm, his hand, his underarm.
It comes from an Arabic phrase that means armpit of the giant.
Well, that's where his arm is, up that far, where Betelgeuse is.
That's for the clay. He's holding a club up there.
There's
Yeah.
a great discussion on that in the what is Sky Safari when you get the information on Jupiter. I mean on Betelgeuse. The first it's a big paragraph on the origin of that name. So that armpit of the great armpit of the great one or the armpit of the giant is just probably the end kind of culmination of it all.
Yeah.
Is it the same word, just a different spelling as the Michael Keaton movie?
Same spelling.
Same spelling.
Yeah, but don't say it 3 times.
I think the movie spelled with like beetle, Beetle.
Yeah,
Well,
they
and then
they
beetle
do
and then
misspelling
juice.
of
Yeah.
Right.
it. Beetlejuice for me is like the word nuclear.
Yeah.
It's
It's
nuclear.
Betelgeuse.
Yeah. Wow.
It comes from El Beit El Jauza, which, like Tim said, means something like armpit of the central one or armpit of the giant.
Uh-huh.
Well, I thought it was another word for Satan.
No.
No,
Not, it's
that's
Beelzebub.
Beelzebub.
We had I think at one of the star parties, we had kind of bad scene. I guess it was ours, and people wanted to see they wanted to see Beetlejuice, and I panned over to it, and it was great because the bad scene gave it a lot more color. And so you really could, just fuzzed it out, and you could really see that red. So that was one good thing. Go ahead.
Bad seeing is really good for like the Cub Scout stars.
Yeah, I got the winter alberio as well, and they were saying, "Oh, I see that color." How can you miss it?
I suppose that Gaia mapping of the the galaxy came up with anything new about all those Orion stars that we didn't know.
The bright stars are much harder for it to get a good position on
Is that right?
because they saturate more of the pixels.
But even though they look together to us in the sky, they're probably all
Yeah, they
far.
have no trouble seeing them. It's just the astrometry of them, just measuring them.
Yeah.
Do we know any more now about alberio?
No, I don't know. I haven't heard anything about Gaia from it.
Okay.
Well, gentlemen, anything coming up soon other than the first general meeting, the first Friday, 7th, Chuck, that we can
We have a couple of schools, but that's it. A couple of schools and then an AU event, not a public event, out of Hollister Ranch.
Okay. Well then, gentlemen, we will retire ourselves, and that'll be it for number 204 of the Astro Hour. Guys and myself would love to have you back here next week for the last, I guess, week of the month of January. Astronomy RS. See you Monday morning for number 205.
I'm going to be a lot older. I'll be a lot older.
Say an infamy.
Happy birthday.